Hi, so welcome to this lesson on converting recurring fractions into, recurring decimals into fractions. Just as a reminder for those of you who might be a little bit rusty on these, remember that a recurring decimal is a decimal that goes on forever with a certain pattern. Quite often we see it with just the one number, so in this case we'd have 0.77, the 7 is recurring, you see, and it goes on forever. We obviously can't write that forever, it'll be a waste of time, we'd never get there, so we put a little dot over the top of the 7 to indicate that it's just going to go on forever. Okay, now we want to convert it into a fraction. I really love doing these because it kind of feels like magic. It feels like, I don't know, it feels like it shouldn't be possible, but it is. Okay, so I think you'll enjoy doing them. And what I'm going to first of all do is I'm going to put x equal to 0.7 recurring. Okay, so I'm going to say let x equals 0.7 recurring. Okay, and then I'm going to say therefore 10x, and just remember that's therefore, 3 little dots, 10x equals 7.7 recurring. And I'm just going to write those out a little bit bigger. Okay, I'm just going to grab another colour pen just so it doesn't get muddled in. But essentially what we've got there is x equals 0.7777, etc. And then we've said, okay, well let's multiply that by 10 and get 10x. So of course every digit here moves one place over. So we end up with 7.7777, because of course these 7s are never going to run out. Okay, they're going to go on forever and ever. So we've essentially bumped it up, so we've got 1 over here by multiplying by 10, and then actually these are going to carry on. Now if you prefer to write them like that, that's absolutely fine. Okay, it certainly makes it a bit clearer what's happening while you're first getting used to these at least. Essentially in the end though, you'll end up doing it looking a bit like this. Okay, so if we know that, and we've kind of defined that, so x is 0.7 recurring, so therefore 10x is 7.7 recurring, we can say, okay, so we're going to do 10x subtract x. Okay, that's what we're going to do, that's our maths. So let's just write those out, and I'm going to do it one above the other, just so you can see what's happening. Okay, I'll do it over here with this kind of long written out method. So we're going to have our 10x at the top, 7.777. I'm just putting a load of 7s, I haven't counted if they're the same number because of course it goes on. And we're subtracting 0.777. Okay, and when we subtract that, what actually happens is that all of these 7s here actually cancel out. Okay, because you're taking an infinite number of 7s away from an infinite number of 7s, so actually they all disappear, and we end up with, oops, hold on to that paper, we end up with 7.00000, which of course is 7. Okay, so that's what happens, and what we've done is actually a little bit of mathematical trickery to get rid of all of those recurring decimals. Okay, so we've ended up with a 7. Now the way we want to write this down, of course, is a little bit more succinct than this, but this is, I just kind of want to explain to you how or why that works. Okay, so if we've got x equals 0.7 recurring, and therefore 10x equals 7.7 recurring, the calculation that we're actually going to write out is, if we've got 10x minus x, okay, oh, I've missed out an x, I thought something looked strange, equals 9x. Okay, so we actually end up with 9x equals 7. Okay, because that's our 7 from here. 10x subtract x gives us 9x, and actually the calculation that we've done there, 10x subtract x, is 7. So we get 9x equals 7. Okay, and then we can actually solve that for x, which is 7 over 9. And just to remind yourself where that came from, we said let x equal 0.7 recurring, so therefore we know x equals 0.7 recurring, which also equals 7 over 9. So 0.7 recurring as a fraction is 7/9. And if you type that into your calculator, you would get, let's just see, can we see that? Okay, 7 divided by 9, which is 0.7 recurring. Let's try another one. Okay, so this time we've got 0.5 recurring, and we're going to convert this into a fraction. So once again we're going to say let x equal 0.5. I'm going to just do it with all of these 5s, okay, for this one. So let x equals 0.5, and those the kind of ellipses, those 3 dots, are just to indicate that that continues, that pattern continues. So we can say, therefore, 10x equals 5.55555 dot dot. Okay. And then actually we're going to subtract them. So the nicest way, the last one obviously we did a lot of talking, but I'm just going to show you a really nice way to present this, okay? We're going to write 10x equals 5.5555 and so on, and we're going to put the x below it, okay? I'll swap them around and you're going to see why in just a moment. Because now I can actually subtract everything, okay? So if I do a subtraction here, do 10x subtract x, put a line there if it helps just to clarify that, is 9x. And then 5.55555 subtract 0.55555 is going to leave us with, all of these are going to cancel each other out, and we're just going to get left with 5. Okay, so now we see that 9x equals 5. And then we just go ahead and solve that now for x. So we get x equals 5 over 9. Okay, and so therefore we can actually write it like this. Therefore 0.5 recurring equals 5/9. Okay, so yeah, that's kind of like the model kind of presentation. That's really how we would write these out. Now the next one's going to be a little bit different. Same method, but a bit of an explanation as to why we've used 10x here. Okay, so this time we've got 0.47 recurring. Okay, and we want to convert this into a fraction. So when we've got 2 dots over the top, that essentially means that this is going to be a pattern that starts with the 4 and ends with a 7, and then continues. Okay, in a moment you will see one like this. Okay, and this is a pattern that starts with the 1 and ends with the 5. So this one here is going to go 0.474747. This one will go 0.135135. Okay, the dots symbol indicate like the start and the end of that sequence. So this one here, we're going to say let x equals 0.4747. I'm just going to write it out 3 times, but with some ellipses there. And then we can say then. Now this time, if I wrote 10x, well, let's see what happens actually. I'm going to write it as 10x just so you can see what happens and why. Because up to now that's what we've been doing. 10x will give us 4.74747 and so on. Okay, 4.7. Okay, and now we're going to get into a bit of a problem. Because as you can see before, we had this lovely pattern where actually we were lucky because we only had the one number, but these all matched up with the one above them, which was lovely. Okay, the problem we've got here, these aren't going to match up, so they're not going to cancel each other out. Okay, so what we're looking for is which multiple of 10 can we multiply by so that we get enough digits to the kind of to the tens, units, hundreds side over here, and we get to continue that pattern. And in this case here, we'd want 100x. So if we multiplied by 100, with the 4 and the 7 would end up over here, we'd get 47.4747. So as you can see, these all start to match up now, so that's going to let us cancel them out in a moment when we subtract them. It wouldn't have worked here. I'm hoping you're able to see why there, okay, because we don't have the matching digits, so we're going to get rid of that one. And we're going to use 100. Right then, so now we're going to do 100x. I'm just going to write them out as before. So 47.47 and x below it. Okay. Oh, dear me. carried away with the 4s and 7s. Okay, your eyes can start to go funny looking at these for so long. And we're going to subtract, and because these match up beautifully, then we can just, they cancel down to the 0 and we get 47 minus 0 essentially. We end up with just 47 on this side. And on this side here we get 99x. And so to solve that for x, we get x is 47 over 99, which equals 0.47. Just like that, okay? Okay, so on this one we've actually got 0.135 with the recurring signs above the 1 and the 5. So that tells us that when we define this, we're going to have that x equals 0.135, 135, 135, etc. Because, as I said before, this kind of indicates the start and the end of the pattern of the sequence. And then we're going to this time have to multiply by 1,000. 1000x equals 135.135.135.135. Okay, multiply by 1,000, so I've got this same recurring pattern down here. Okay, so it matches up. Then we can write that out to do the full calculation of that subtraction. So 1000x equals 1. And then we have got below that x equals 0.135 recurring. Okay. As I said before, I'm not writing these to any kind of accuracy, I'm just writing it so it's long enough to see the pattern there. You know, these are recurring, so they go on forever. And then we're going to do that as a subtraction. So as you can see, these all subtract down to give 0, 5 subtract 5, 3 subtract 3, 1 subtract 1, etc. And 135 subtract 0 is 135. And then on this side we've got 1000x subtract x, which is 99x. And then we're just going to 990. I thought something seemed a little bit odd then. There we go, 999x. And then we're going to divide through by 999 to get 100 x. So x equals 135 over 999, which equals 0.135. Like that. And the nice thing about these is that actually you can always check them on your calculator afterwards. So if I do 135 divided by 999, you can see there I do get this recurring decimal here. Okay, so that is the really nice thing. Excuse me. That is the really nice thing about these. You can always check them. There's no there we go. Yeah, there's no reason to not get these right by the end of things because you can actually check them. Okay, take care with those. Bye bye.